These are the practice problems for lesson 14, using linear relations to solve problems. And problem number 1 has tables that seat 2 people and tables that seat 4 people in a restaurant. And the total number of people that you can seat in that restaurant is 120 people. And the owner wants to know what are some different combinations that he can have of tables that seat 2 people and tables that seat 4 people. So you want to describe some possible combinations, write an equation, create a graph, what does the slope of that graph tell you, and then figure out what the y-intercept is and the x-intercept, and what do those numbers mean. Okay, this is very much like the fish problem, the fabulous fish problem of activity 14.3 and the extensions. So instead of fish, you have tables, and instead of money, you have number of people that can be seated at each of those tables. So let's figure out how many tables you can have if you have an equal number of tables that seat 2 people and an equal number of tables that seat 4 people. So in this case, I'm going to use 1/2 of the number of tables that seat 2 people and half of the number of tables that seat 4 people. I'm going to call this yx so I can work with all x's, and then we'll go back to y down here. So half of the tables can seat 2 people, so that's 1/2 or 5/10, which also, by the way, is 50%. This is also 50 hundredths, 5/10, 50%. That's all the same. So half of 2 is 1. It's 1x. Half of 4 is 2. That's 2x. Add those together, you get a total of 3 people on average. And that makes sense. If you take one table and you seat 2 people, and you take another table and you seat 4 people, that's 6 people seated between 2 tables. And 6 people divided by 2 tables is 3 people per table. So this makes sense that the average number of people that you can seat at each table, if you have an equal number of tables, is 3. And how many total people are you going to seat? That's 120 people. So every time I take out 3 people, every time I seat 3 people, that's 1 table. How many times can I do that? 120 divided by 3 is 40 times. This is 40 total tables. Now half of these tables are going to seat 2 people, and half of these tables are going to seat 4 people. So half of 40 is 20 tables times 2 people. That's 40 people that I can seat at 20 tables, and half of the number of tables, half of 40 is 20 tables at which I can seat 4 people. So 4 times 20, so here's the 20, 4 times 20 is 80 people can be seated at the tables that can seat 4 people. So you add those two numbers together, that's the 120 people. Now instead of looking at this as a single table, this is viewing it as a single table, and then when you figure out x, you get 40 total tables. Let's look at it as 2 tables. One table can seat 2 people, and the other table can seat 4 people. So that means I can seat a total of 6 people. So every time, so I have 6 people walk up and want to be seated, 2 of them go to one table and 4 of them go to another table. So how many times can I do that? So this is like the fabulous fish problem, in which we bought pounds of fish, but in this case we bought 1 pound of fish of tilapia and 1 pound of fish of salmon. So in this case it's 1 table that seats 2 people and 1 table that seats 4 people. So I can seat a total of 6 people. How many times can I do that? I can do that 20 times. So x, the number of people I can seat at 2 tables, the number of tables I can seat 2 people is 20, and the number of tables I can seat 4 people is also 20. So 2 times this 20 is equal to 40 people. 4 chairs per table times this 20 is equal to 80 people. Add them together, you can seat 120 total people. So why is this x equals 20 and this is x equals 40? This was working with one table in the beginning. So when we figured that out, we got 40 total tables, while this was working with two tables in the beginning. And when we figured this out, we got the number of tables for x and the number of tables for y. So that 40 got split between x and y. Okay, so what does a graph of this look like? You have the equation, which is x is the number of tables that can seat 2 people, y is the number of tables that can seat 4 people. And the total number of people that can be seated is 120 people. So this goes back to, you have 2 chairs plus 4 chairs equals 120 people. And how do you change everything to people? Well, you have to realize that it's 2 people per chair per table and 4 people per table. So it's 2 people per table times the number of tables, 4 people per table times the number of tables, and that all together equals 120 people. But what if we had all tables that can seat 4 people, 4 chairs per table. So let's make x 0, so we don't have any tables that can seat 2 people. All tables seat 4 people. So x is 0. So y is going to equal this 120 people divided by 4. It's 4 people per table. So 120 divided by 4 is 30 tables. So y, where x is 0, y is going to be 30. So it's going to be right here. But let's say, on the other hand, let's say that we had all tables that can seat 2 people. So 2 chairs. Well, y is going to be 0 in this case. X is going to equal, so 2x is going to equal 120 people. 120 divided by 2 is equal to 60 tables. So if we have all tables that can seat 2 people or 2 chairs, that's going to be 60 tables. That's going to be out here. So this goes from 30 tables, that's the y-intercept, so only tables that can seat 4 people, to 60 tables, that's going to be the x-intercept, so only tables that can seat 2 people. And this line is every combination that you have where you have the number of tables that can seat 2 people, the number of tables that can seat 4 people, and together that total number of people that can be seated is 120. So this line is always adds to 120, and it's split between tables that can seat 2 people and tables that can seat 4 people, but always equals 120 people. So this slope is a negative 1/2. So every time I add the ability to seat 40 people, that's 20 tables. So every time I add 2 units, I can seat, in this case, for 20 tables, I can seat 40 people. Then I have to subtract the number of tables that I can seat 40 people that are equal to 4 chair tables. Sorry about that. And so that is how many tables can seat 4 people to seat 40 people. That's 10 tables. So I have to, if I'm going to add 20 tables along the x-axis, I have to subtract 10 tables along the y-axis. Well, that's, if I increase this 20 units and I decrease this 10 units, that is a slope of a negative 1/2, a negative 10 over 20. So every time I increase this 2 tables, I have to decrease y 1 table, because I increase this 2 tables, I can seat 4 people. I decrease y 1 table, I can also seat 4 people. So I always have to keep that number of people balanced. This is where you use a standard form of the equation to keep the number of tables for x and the number of tables for y balanced to always be able to seat 120 people. So if I increase x, I have to decrease y. That is why the slope, by the way, is a negative 1/2, because you have to decrease y if you increase x. So for every 2 chair tables, I can seat 4 people, I have 4 chairs. So for every 2 of these tables, I have to remove 1 of these tables, 1 4-chair table. So 2x plus 4y equals 120. And you can get the slope from the standard form of the equation as well. It's a negative 2/4, a negative 2/4, which is equal to a negative 1/2. So if you change this form to the slope-intercept form, so I'm going to add a negative 2x to get rid of this 2x and to move that 2x over here. So now this is going to become the slope in a moment. If I divide through by 4, then this is a negative 2/4, and 120 divided by 4 is 30, and this is a negative 1/2. So you get that slope of a negative 1/2. So if I'm going to increase this 20 tables, I have to decrease y 10 tables. It's the same, seating the same number of people. So I can seat 40 people. I have to remove the ability to seat 40 people. All right, so let's look at these side by side one last time. So this is where it's 50% of the number of tables can seat 2 people, and 50% of the number of tables can seat 4 people. You get an average per table of 3 people per table. 40 total tables. Half the number of tables are 20 tables that can seat 2 people. Half, this 5/10 right here, of the number of tables. Half of 40 is 20 tables that can seat 4 people. So along this side I can seat 40 people. Down this side I can seat 80 people. And that's a total of 120 people. But again, if you look at it as just whole tables and seating 6 people at a time, you can do that 20 times. So x is equal to 20 and y is equal to 20. I could add a graph of the equation y equals x, because the number of tables for x is 20 and the number of tables for y is 20. So y does equal x, shown here with this little figure. And that graph would go through 0, 0, and it would go through 20 tables that seat 2 people and 20 tables that seat 4 people. So it'd go through 0, 0, 1, 1, 2, 2, 10, 10, 20, 20, 30, 30, 40, 40. So that would be a graph of where the number of tables that seat 4 people equals the number of tables that seat 2 people. And where this graph intersects this graph, or this line, that is where the total number of people that can be seated is 120 people. So that point is the solution both for this line, where 2x plus 4y equals 120, and it's a solution for a graph of this line, which would be a graph of this equation, which would be y equals x, where 20 equals 20. Problem number 2, in which you have a triangle that's an isosceles triangle. So with 2 angles that measure x degrees, so it's an equal number of degrees. So 2 angles are an equal number of degrees called x, and 1 angle is y degrees. So the remaining angle is going to be y degrees. And so find 3 combinations of x and y to make this sentence true. Write an equation, sketch a graph. So remember that all triangles, the angles of the 3 angles of every single triangle always add to 180 degrees. So now I have 2 angles that are x degrees that are equal, and a third angle that's y. So those 3 angles have to add to 180 degrees. Well, if I make one angle 10 degrees, then I have 2 angles that are equal to 10 degrees. So 2 times x is equal to 20 degrees. And so the remaining number of degrees have to equal y. So 180 degrees minus 20 is equal to 160 degrees left over. So that has to equal y. If I make x 50 degrees, I'm going to double that to 100 degrees and subtract this 100 from 180. So the remaining number of degrees has to equal y. It has to equal 80 degrees. If I make x 80 degrees, I have 2 angles that are 80 degrees. So I'm using up 160 degrees. That means I have 20 degrees left for y. So notice in every case, I'm taking the number of degrees for x, that's 2x, plus the number of degrees for y, that's y, and adding them together to equal 180 degrees. 2x plus y equals 180 degrees. 2x plus y equals 180 degrees. So the equation is 2x plus y equals 180 degrees. And the slope is -2, because every time I add a degree for x, that's adding 2 degrees total, because there's 2 x's. And so I have to subtract 2 degrees for y, so I have to subtract 2y. So every time I add 1x, I have to subtract 2y. So that's a -2. I have to take 2 away from the y degrees for every 1 degree that I increase x. So that's a slope of -2. Each 1 degree increase in x equals a 2 degree decrease in y, because there are 2 x's. So every 1 degree increase in x is increasing the total amount 2 degrees. So you have to subtract that total from y to always have this equal to 180 degrees. Remember, it's a balance. That's why we're using the standard form of the equation. If I increase x by a certain number of degrees, I have to decrease y by that same total number of degrees. So there's 2 angles that are equal to x, so decrease y by 2 degrees to equal 180 degrees. So here's 2 x's. If I increase x, I do that to both of these angles, so I have to subtract that number of degrees from y, both of these, from y, to get an equal decrease in the number of degrees to keep it always balanced with 180 degrees. So an equation would be 2x plus y equals 180. So now let's say that all of the degrees are equal to x. So y is going to be 0. What's x? Well, 2x is equal to 180 degrees. So 1x would equal 90 degrees. So if y is 0, y is down here, x would be 90 degrees. Well, x cannot be 90 degrees and have a triangle. So x has to be anything less than 90 degrees. So it's going to approach, it's going to get really, really, really close to 90 degrees, but it has to be less than 90 degrees, because you have to have some degrees remaining to make angle y. Now let's say that all of the degrees are equal to y and x is 0. So if x is 0 and all the degrees are y, that means y is going to equal 180 degrees. But y cannot equal 180 degrees. It has to approach, it has to get really close to 180 degrees, because you have to leave some degrees available to form x. And actually that's 2 x's. That's 2 angles with a equal to x. So y can approach 180 degrees, but it has to be less than 180 degrees. And the slope is still -2. And you can get that from this standard form of the equation. It's -2/1, because I have to decrease the degrees in y for every increase in the degrees in x. And I have to decrease this 2 degrees for every 1 degree increase in x. So that's a slope of -2, a -2/1. So if I graph the examples in the previous, that we used previously, 10 degrees for x, I have I'm using 20 degrees because there's 2 x's, and so that means I have 160 degrees remaining to form y. So if x is 10 degrees, y is going to equal 160 degrees. So remember, they add together to equal 180 degrees, this point right here. If I have 50 degrees for x, I'm going to use that twice, and so I'm going to use up 100 degrees of the triangle. That means I have 80 degrees left. 180 minus 100 is this 80 degrees, and remember, they have to add together to equal 180 degrees. If I'm using 80 degrees for x, I'm using up 160 degrees because I have 2 angles that are equal to x. So I'm using 160 degrees. That means I have 20 degrees left. 180 minus 160 equals this 20 degrees for y. And remember once again that those two angles, actually three angles, two x's and one y, have to add together to equal 180 degrees. So 2 times x, 20 degrees, plus 160 degrees equals 180. 2 times x, 100 degrees plus 80 degrees equals 180. And 2 times x, 2 times 80 is 160 degrees plus 20 degrees equals 180. So each of these points are solutions to this equation up here. 2x plus y equals 180 degrees. So 2x, x is 50, y is 80. So 2x plus y equals 180 degrees. X is 80, y is 20. So 2x plus y equals 180 degrees. So each of these points, once again, are a solution to this equation. Put them in for x and y, you get 180 degrees. All right, the slope-intercept form of this equation you can get from the graph, or you can work through the algebra to figure out that y equals a negative 2x plus 180. So we figured out that the slope is a negative 2, and you can get that from the graph, or you can get that from the standard form of the equation. So every unit increase in x is a 2-unit decrease in y. So if I increase x 1 unit, right, let's say 1 unit is from this y-axis to this point right here, I have to decrease y 2 units. That'd be 1 of these, 2 of these. Increase 1, decrease 2. Increase 1, decrease 2. Increase 1, decrease 2. So that's an increase of 10 degrees, a decrease of 20 degrees, an increase of 10 degrees, a decrease, whoops, sorry about that. Increase of 10 degrees, decrease of 20 degrees, increase of 10 degrees, decrease of 20 degrees, and so on. So it's for every 1 degree increase, you have to decrease y 2 degrees. So that's a slope of negative 2. This is problem number 3, in which you are supposed to check each of these equations to see if point -6, -1 is a solution to these equations. And there are a couple ways, at least a couple ways to do this. I'm going to show you 2 ways, plus I'm going to graph each of these equations and show you what this solution to the equation means on a graph. So what I chose to do first is just replace x with -6 and y with -1 and solve each side to see if they do in fact come out to be equal. So in the first case, 4 times -6, so replacing this x with -6 equals -24. A -24 plus a positive 23 equals -1. So both sides are equal. Y is -1, and when you solve for the right side, you get -1. So A works. B, x is -6, so 3 times -6 is -18. Y is -1. A -1 times 1/2 is a -1/2. They are not equal. So B does not work. B, -6, -1 is not a solution for B. For C, 2 times -6 minus 13 times -1. So y is -1 equals 1. So this is -12 minus a -13. So -1 times a positive 13 is a -13. So now I'm going to add the additive inverse. In order to combine these 2 terms, you can call them, I'm going to add the additive inverse. So that's a -12 plus a positive 13. -12 plus a positive 13 equals 1. So in fact, you do get 1 equals 1. So that does work. So C works. D, y is -1. So 3 times -1 is -3. And x is -6. So 1/2 of -6 is also -3. So D works. And the last one, x is negative 6, y is negative 1. 2 times negative 6 is negative 12. A negative 1 times 6 is the opposite of 6, is a negative 6. Combine those two terms, you get negative 18. That does not equal this negative 6 here, so that does not work. So the three equations that work, A, C, and D. So this point is going to be on a graph of each of these three equations. Now they're different graphs, they're different lines, but they're all going to pass through this point, negative 6, negative 1. I'm going to show you that in a moment. So the next thing I did is I rewrote each of those equations in the slope-intercept form. That way you can just solve for y. You replace x with negative 6, and then you solve for y and see if you get the value of negative 1 for y. So y equals, and this is already in the slope-intercept form, so just replace x with negative 6, and y does in fact equal negative 1, which is the y coordinate. So again, I'm going to rewrite this equation in the slope-intercept form. That is y equals 6x. So you might practice doing that. So you can put this term, the y term, on the left side and the x term on the right side. Just switch them. You can do that. And so now I want to get it in this equation into the form of y equals mx plus b. So I have 1/2 y equals 3x. Multiply through by 2, so you get y equals 6x. So now just replace x with negative 6. Do you get y equals negative 1? And in fact, you do not. So this b does not work. C does work. So without going through all the steps again, you're going to get this to the form of y equals 2/13 x and minus 1/13. Or you can say this is plus a negative 1/13. I think that's a better way to write it. It's right here, plus a negative 1/13. I think that's a better way to write this. So you might practice getting this equation into this form and then replace x with negative 6 and solve. So negative 6 times 2/13, go through and solve that, and you get a negative 13/13, which is the same as negative 1. So C does work. So this is good practice, using fractions, changing the form to a slope-intercept form, solving by replacing x with negative 6. This one is good to practice on. D, y equals 1/6 x. So you multiply through by 1/3. This is the multiplicative inverse of 3. So 1/2 times 1/3 is 1/6. So you get y equals 1/6 x. Replace x with a negative 6. Y equals negative 1. So D works. For E, get this equation into the slope-intercept form. So you're going to move the positive 2x over to the right side. So that becomes a negative 2x plus negative 6. And you divide through by the 6. So this becomes a negative 1/3 x plus a negative 1. So y, this is the slope-intercept form right here. So y equals a negative 1/3 x plus negative 1. Replace this x with negative 6 up here. So y equals a negative 1/3 times a negative 6 plus negative 1. So work through this. You're going to see that a negative 6/3 is equal to negative 2, but the opposite of that negative 2 is positive 2. So this is equal to y equals a positive 2 plus a negative 1. So 2 plus a negative 1 is equal to positive 1. That is not negative 1. So E does not work. So now if we go through and draw graphs for each of these equations. So I did that. I'm not going to go through this in too much detail, but I want you, and you might do this on your own. What I want you to see is a graph for A. So you know the slope-intercept, that's 23. You know the slope. I'm sorry, the y-intercept is 23. You know the slope is 4. So you just use that information to draw this graph. Same kind of information to draw graph B. This goes through 0. This is a proportional relationship that goes through 0, 0. BC is over here. This one is the hardest one because, you know, working with a weird fraction. the y-intercept is a negative 1/13. So you just have to kind of make a guess where that is. And the slope is 2/13. So that's kind of tough. You go for every 13 units to the right, 10, 11, 12, 13, you go up 2 units. And it's from, remember this is to be a negative 1/13. A little bit tough, but you might try to do it. D is easier. This is a proportional relationship through 0, 0, and it has a slope of 1/6. And E goes through the y-intercept is negative 1 and has a slope of negative 1/3. So you graph each of these and extend them out. You have to make sure they go far enough in each direction to possibly, if they do, go through this point, -6, -1. So this is the point of interest. Is that point on these graphs that where this point is the solution to the graphs? And it is on the graph for A, D, and C. That's what we figured out. So this point, -6, -1, is on each of the graphs for each of those equations because it is a solution to each of those equations. It makes each equation true. This is problem number 4. It says, consider the following graphs of linear equations. So this graph right here of M and this graph right here of L. And decide which line has a positive slope and which has a negative slope, then calculate each line's exact slope. So first of all, if you move in a positive direction along the x-axis and a positive direction along the y-axis, that is a positive slope. So you're going to the right or in a positive direction and along the y-axis in a positive direction. So remember, it's the length along the y-axis divided by the length along the x-axis. If both of those values are positive, then the answer is going to be positive. It's going to be a positive slope. On the other hand, if you move along the x-axis in a positive direction but along the y-axis in a negative direction, so this length right here is going to be a negative value. So a negative divided by a positive will give you a negative slope. So now you're moving down from the top left to the bottom right. Positive slope is from the bottom left to the top right. So once again, positive slope, positive x, positive y, negative slope, positive x, negative y. So now I'm going to calculate the exact slope using these points, and I'm going to call this point the end value and this point along this line the end value, and they're both going to start at the same spot. They're going to both start at 520. Now notice the scale of each axis. This is 1 unit each, 1, 2, 3, 4, 5, but this is 20 units each line. So this is 20, 40, 60, 80, 100. So I'm going to start here at the point 520, and I'm going to end at 880. So I'm going to subtract the lengths along the y-axis first. That's how much is changing along the y-axis. So I'm going to take this 80 units and I'm going to subtract these 20 units right here. And I'm going to divide that by the change along the x-axis. So I'm going to take these 8 units here along the x-axis and subtract these 5 units here along the x-axis. So this is 8 minus this 20. So that's how much the y-axis changed, the y length changed. And this is 8 minus this 5. That's how much the length along the x-axis changed. So that gives you an answer of 60 divided by 3, or a positive 20 units. So for every unit I move along the x-axis, I have to move 20 units up along the y-axis. So over 1, up 20, over 1, up 20. That's a slope of positive 20. So now notice for the line M, starting in the same spot, but now I'm going to subtract that point at the start from where I end, which is the point 8, negative 40. So notice that it's negative 40 minus the y coordinate, so that's 20. So negative 40 minus 20 is a negative 60 units. But up here it was 80 minus a positive 20, that's a positive 60 units. So this slope is going to end up being a negative 20, because I'm going to divide that negative 60 units, so negative 40, this negative 40 minus this positive 20, so I'm taking away this little bit right here. So what am I left with? I'm left with, and you're subtracting that from negative 40, so I'm left actually with negative 60. So negative 40 plus a negative 20 is equal to negative 60, and the change along the y-axis, or I'm sorry, along the x-axis is the same as before. You're taking away the same 5 units from these same 8 units. You go out along the x-axis 8 units for this point, and along the x-axis those same 8 units for this point. So it's that 8 units minus this 5 units. So 8 minus 5 is 3. So you have negative 60 divided by 3. That's a negative 20. So the slope for line M is negative 20. The slope for line L is positive 20. So negative 20, for each unit you move along the x-axis, you have to move down 20 units, negative 20. So 1 unit down 20, 1 unit down 20, 1 unit down 20. For positive slope, it's 1 unit up 20, 1 unit up 20. So this is a positive 20, this is a negative 20.